Welcome everybody to this new Pix4D webinar. My name is Oliver Kung, I'm co-founder of Pix4D, and today's topic is ground control points.
So let's start with the agenda. The few topics we're going to discuss today is we're going to start first with an introduction to the ground control points, just to define what they are and why actually we are needing them, and actually go a bit more in theoretical detail, both for the georeference part and the accuracy. Then we'll go step by step, and I'm going to show you in Pix4D Mapper how to insert ground control points the most efficient way. Of course, then we'll discuss about how to assess the accuracy of these ground control points that we just inserted, both in the quality report as well as also the rayCloud. We'll answer then a question which has been asked very, very often about how many GCP do you need and where do you place them in your project, and we'll give many answers to actually these questions. We'll also go over the most common errors that our support team has been seeing with the users of Pix4D Mapper on which problem they encounter when related to ground control points. I'll also talk about a feature which has been introduced in the version 1.1 of Pix4D Mapper, which is about the tolerance of the geotags and ground control points, and conclude with an alternative way of adding ground control points in Pix4D Mapper. All right, so let's start with the simple question. What's a ground control point? In most cases, a ground control point is basically a marking on the ground measured by a high precision GPS. Then you acquire your imagery using your UAV or your drone of this area where you marked on the ground this GCP. And just before processing, you include the measurement you did with your GPS inside of the project to enhance the georeferencement and the accuracy. However, it's a bit more broad than that. You can actually also use any type of feature which is easy to recognize on the ground, such as a building edge or roof. The only thing is it has to be significantly recognizable in the images, because as you can see in this example, it's very easy to see it on the left when you take it from the ground, but at 100-meter altitude from a drone, it looks a bit more differently. So I would advise to choose something with very high contrast. Now, why would we actually use ground control points? Why actually would we actually add ground control points to a project? I would say there's mostly two reasons for it. Reason number one is about providing a great georeferencement to your project. And reason number two is about improving the relative accuracy of your project. So let's go first talk about reason number one, georeference. Pix4D Mapper is able to reconstruct, to calibrate a project fully just from the images only, without any information about geolocation or GCP or anything. However, if you just take images without geotags and GCP and put in the software, you will get a 3D model which is relatively correct. So if you take the proportions, they will be correct, but measuring in it will be wrong, mostly because from images only, you cannot get the scale, the orientation, and the position of your project. These are unknown. What Pix4D Mapper is going to do for you is going to position it around a value 0. It's going to orient it in some way, but it doesn't know if it has to be upside down or if it has to look on the right, on the side. So it may very well happen that just as in this picture, you get your project upside down, and it doesn't know if it's 1 centimeter or 1 kilometer project. However, this is usually not happening because you are including geotags in your project. if you have geotags, then your 3D model, the position of the camera, is going to try to fit during the processing this geotags, and this will give the proper georeferencing, meaning the scale, position, and orientation of the project. Well, this would be good if your geotags would be perfect, but in most of the projects you're going to process, especially in the UAV world, this is not going to be correct, because your GPS tag, the geotag that you assign to the images, will actually have a lot of error there. It's error because on one side it's very far away from the distance you want to measure, the position of the cameras. In addition, it's very tricky to correctly synchronize the time where the GPS fires and where the camera actually takes the picture, to synchronize the exact timing. If you take a few milliseconds of mistakes, if you fly fast, this is going to make centimeters of mistake. But in addition, the most global error that you will have there is that very likely your UAV or your manned aircraft is not going to have a high precision GPS on it. It's going to have a consumer grade GPS. A consumer grade GPS has two types of noise. It has inaccuracy of around 1 meter, which the software has not too many trouble to compensate for, because we can model and incorporate this noise to make a very good measurement from that. But the most problematic is that there is a global shift of around 5 meters. This global shift is basically shifting your automosaic and your DSM and your point cloud in some random direction of around 5 meters, and this is due to atmospheric condition around the Earth, which deviates a bit the GPS signal. And with consumer grade GPS, you don't have a way to correct that. So now that's actually the real reason of introducing ground control point, is that it's much easier to use a high quality GPS surveying tool on the ground than in the air. And the good news is that you only need 3 measurements on the ground to define the whole transformation between the relative space and the real world. These 3 measurements you will do on the ground will define the scale, meters or feet, will define the orientation, to put properly things correctly, and will define also the position. So that's really where the GCP are useful. So that was really for the georeference part, where this is really the most important. Now, I was also mentioning at the beginning that it's not just about georeferencement, it's also about accuracy. And potentially adding GCP is also able to improve the accuracy of certain type of projects. So let's have a closer look where it's useful and where it's less useful. If you have a perfect project with a lot of overlap, good quality images, lots of visual content, the whole project is going to calibrate using the visual content. And if there is a lot of visual content, lots of matches, there will be very little error introduced by matching the images. And you will have a very, very good relative project, even if it's 2,000 images long. And the error that is introduced by mismatches is going to be so small that you're not going to be able to measure it. So in the good case, in this case, adding GCP will not improve the accuracy, because the accuracy is already as good as it can become. However, this is not always the case, and sometimes just in little parts of your project, you have areas which have less overlap or less visual content and less matches. In this case, when you have very little of these matches, it may introduce some error. This error is very little, but the issue is that it may accumulate. And if it happens in the middle of the project, so that would be a side view of your calibration, if it happens in the middle, just half a degree of error, it may propagate and then lead to actually very high errors at the end of the project of potentially several meters. The good news is that by introducing GCP, it helps you to potentially fix this error accumulation error. And in a project where basically you had an error accumulation happening in the middle, if you introduce GCP either on both ends to fix the system or in the middle to avoid this error accumulation to happen, you can fix this error accumulation and have a really nice project overall. Now, one last thing before going into how to insert them in the software is just a small discussion about measuring the accuracy of your project. So, as you can have guessed by now, when you include GCP, this GCP will be used to make sure that when you do the reconstruction, the model will fit as closely as possible to these points, which means basically that we minimize the error in this location. So if you look at the DSM at this area, obviously the error will be close to 0. And measuring to have a global sense of the project, the error, it's maybe not very fair because it may very well at this area it's 0, but then it gets crazy in other places if the matches were not good enough. So a good way to measure the accuracy of your project is to use something slightly different that we introduced also in Pix4D Mapper, is checkpoint. So checkpoint is basically the same as a ground control point. Is also something that you have to mark on the ground, measure with a geodesic GPS, and click in the images. But if you label it as being a checkpoint, the software will not take it into account neither for the georeference nor the optimization. And at this spot, you will be able to get a very fair assessment of the accuracy of your project. We're going to show that just a bit later in more details. So let's go for the demo on how to introduce ground control point in a project. Whoops. So in this project, I have about 43 images taken at about 150 meters altitude with a Canon Xus camera and with an overlap of about 70% frontal and 50% on the side. There's a lot of visual content. This is a very easy project. In this project, just before taking the images with my UAV, I collected on the ground control points. So what I did basically is that I went on the ground with a can of spray, and I made a pattern. You are basically free to make any type of pattern as long as you can identify it well and precisely in the images. Something with a high contrast and a sharp edge is usually preferable because it's easier to click with high precision later on. A good practice is also to take the ground control points, to take pictures of them while you're on the ground, as it makes it much easier to later on know which point is which. While I did this mark on the ground, I also used a GPS, a high precision GPS device, to make measurements in the national coordinate system. So this was done in Switzerland, so I'm using the CH1903 plus datum and coordinate system. The format of the file which you need to create to be able to enter it in Pix4D Mapper is very simple. You start with the name. You can give any random name to your ground control point, then the X value, the Y value, and the altitude, the Z value. You create one line per ground control point and save it in a simple ASCII file. Okay, so let's create a project. To use, I'm going to quickly create a new project. I'm going to do it webinar test. I'm going to include my 43 images. Next. The geotags are already inside of the images, so I don't have to do anything special. Next. Finish. And now I'm able to see the geotags on the satellite maps, and this project is ready to get processed. And the easiest is first to pre-process it without any ground control point information. To do so, you click on local processing and you uncheck point cloud densification and DSM and automosaic generation. These are not needed for making a pre-processing. It will just make things faster by unchecking them, and then you click Start. Just to save a bit time, I've already done this project right there. And this is the status of the project you see just after the... Oh, I need to restart it. Just after the processing of the first step without ground control points. Okay. This is the view of the rayCloud showing the geolocated reconstruction using the geotags only. So once you have done this step, everything becomes much easier to introduce ground control points. And now I'm going to show you how. First, you need to open, using the icon there on the top, the ground control point editor. With this editor, the first thing you have to do is select the coordinate system of your ground control points. As I mentioned before, I'm using the national Swiss coordinate system, which is CH1903+. If your coordinate system is not in this list, you can use either the EastPSG number or even for a very specific project, create your own PRG file. Okay. You can note, by the way, that before it was longitude, latitude, and now it become X and Y, as it detected that it's a planar coordinate system. Then I'm going to click on Import Ground Control Points, and I'm going to browse for the file that I was just showing just before with the ground control point name and the coordinates. The software detected the ground control points, and I just need to press OK, and it includes them all in the project. This interface can be used to introduce ground control points, but I'm going to show you introducing them through the rayCloud, which is much faster and much more efficient. So for now, we're going just to press OK to close the ground control point editor window. You can see now that something changed in my project. There are some blue crosses inside of the project. These are the ground control points that I just inserted. However, they are not at the right spot. They are shifted off a few meters. It can be easily seen that they are not exactly in the right position. This is because what you're seeing there is the shift of the GPS which was included inside of the UAV, which is a consumer-grade GPS. So now a very efficient way to annotate, to mark my images, to make sure that we include these ground control points for the processing, is to simply click on this blue cross, or to select it in the list on the left. And it's going to display me the position of this of the geodesic measured GPS position. Now, as the error that was in the first GPS of the geotag GPS was very little, only a few meters, it's very easy to find back where was the ground control point. It was just next to it, a few meters away. What you need to do as a first step is to click to mark the ground control points in the first image. Then you need to do it for a second one. And click, very important, then to click on apply. If you don't click on apply, the software is not going to record your changes. By clicking on two images, you basically now you triangulated the two images and created a 3D point. This 3D point is going to get reprojected as a green cross in the images. For more information about the reprojection, I would advise to check the webinar about the rayCloud that we did last month. And now this ground control point will be used during the processing. However, there is often the question on how many images do I need to click? Well, this can be answered easily by looking at the rayCloud editor. If you zoom on all the ground control on the reprojection error, which is the green cross, this green cross should be exactly on the same location for each of the images. If it's not, it means that you didn't click in enough images and you need to add some more measurements. This is what I'm going to do. For instance, here I can see that I'm 2 pixels away. So I'm going to add in this image one more measurement. By adding a measurement, it shifts in all the images the green cross closer to where it should be. By doing that in additional image, I can see that now my green cross is in the same corner of all the images, which pretty much means that it's I did enough measurements in my images. You can also notice that there is a yellow circle around it. This yellow circle is related to the confidence of the marking I'm doing right now. Let's take an example. In this ground control point, the image is very, very blurry because it was the UAV was flying quite fast and it was a bit on the border there. Maybe I'm going to just take a break to answer a few questions which are asked to the audience. So somebody is asking about if choosing the corner is a requirement or just a preference. No, this is totally arbitrary. In my case, I decided that when I did my measurement with my GPS stick, I actually took the corner of my square that I painted. If I would have done a cross, I could have done it in the middle. So this is just because when I did the measurement with my GPS, I always set my GPS stick on one of the corner. Okay, so back to this yellow circle. In the case which I'm not very confident about making a measurement in this image, you can zoom out a bit and do the measurement on a lower zoom level. By doing the measurement on a lower zoom level, you will see that the yellow circle will be much bigger. And if the yellow circle is much bigger, it basically tells that this measurement will be taken with less importance than the one you did at a very close zoom level. Yes, so somebody is asking if I should always choose the same corner, and indeed I did select the same corner everywhere. It looks different just because the images are rotated. So in this example, it's the upper top corner. This was in bottom right, but it's just because the images are rotated. but it's the same corner in every images. Okay, once I've done enough measurements, I click on Apply, and now I introduce these ground control points with high confidence. So somebody is asking if it would make sense to actually take the ground control points in the middle of the square I did. Well, if you look at how easy is it to spot where's the middle, actually it's very hard because the images are not of the sharpest quality. Sometimes selecting a corner is more precise than trying to set a middle position, which is hard to spot. So now I'm going to do it, this type of operation, in a few other ground control points. So this is another one. Okay, I remember this was the corner I selected. I click, click, click. I apply. I zoom. I look in all the additional images if the reprojection is at the correct area. Yes, it is. Okay. I can help a bit. This one is very blurry, so I'm less confident, so I zoom out a bit before making the measurement. Okay. Click Apply. And in this project, I have 8 GCP. So what I'm going to do is I'm going to choose 5 as being GCP, and 3 of them I'm going to label them as checkpoints to allow me to assess the accuracy really in a fair way. To do so, you click on your ground control point. Again, you make your measurement, click Apply, you zoom. Okay, this is less accurate, so I'll take less zoom. Up. This looks good. Apply. And now, if you double click on the type, which is written there, with a double click, you get access to a menu. This menu allows you to change from GCP to checkpoint. Click Apply again, and you will get this GCP being a ground control point, being a checkpoint. So now I'm not going to do all 8 ground control points. This would take a bit too much time, but let's imagine that I would have clicked and marked in all my images my 8 ground control points and applied each of them. To include this measurements now in the processing to find the correct position of the camera, including all of that, I'm going to click on Process and Re-Optimize. This is going to be much faster than the first step and will basically take my ground control point information to geolocate and to minimize the error at the ground control point. So just to save time again, this is something I've already done in this project over there. And by reprocessing, you can now see that the error between the blue, which is the merged GPS, and the green, which is the triangulated type point position, is very, very close. So now first, how to assess the quality of this ground control point and checkpoint. There are 2 ways basically to get a better feeling about how accurate were my ground control points measured, taken into account and everything. The first way is using the rayCloud editor. So again, after processing, you click back on the ground control point. On the top of the image view, you get a few numbers over there. These numbers give you some estimates and some indication about the accuracy of this measurement. The first number is a number which basically relates the variance between the yellow and the green cross. Basically, it's the reprojection error and tells you how nicely did all the ray join together to make a 3D point. This value should rather be below 1 to get good results. The second value you see there is the theoretical, basically the covariance of the error at the point where you did the triangulation. It's a bit more complex value. This is really something much more for photogrammetrists, but something as an easy way to check is that the third part is very often larger than the two other ones, or at least they should be comparable. The third value you get there is the maximal orthogonal ray distance. It basically tells, it's going to warn you if there's a ray which is too far away from all the others. If the value is high, so this should be meters, if the value is bigger than the accuracy of your GPS, it's very likely that one of your click was not done correctly. So if this value gets very high, you should check back in your project if one of your click was wrongly clicked or not. So let's assume that I wrongly click one, I mislabel and I've wrongly clicked in one of the image. You will start to have extremely high value there, which will tell you very much that there's an issue in your clicking. Finally, you have the error between the green cross and the blue dot, which is the green is a reprojection and the blue is the GPS. And the error will be displayed in meters over there. This error is also reported inside of the quality report. So after processing, after reprocessing, reoptimizing the step 1, you get a new quality report. In this quality report, you can see the ground control point, which each have a label. They have the error, which I just mentioned, which is the Euclidean distance between the GPS and the triangulated point that you just measured. You get the reprojection error for each of the GCP. And you get both the value, the number of times that you clicked in the images. So for the GCP number 12, I clicked in 9 different images. And the software is going to be quite smart and is going to tell you if one value, one of your click looks really way too crazy, way too ahead, it's going to try to identify it and it's going to remove it from the computation in order not to introduce error. So from this ground control point, we're going to compute the mean, the sigma, which is basically the standard deviation, and the root mean square error, which is a combination of the mean and the standard deviation. I get very small error, which is quite normal. Basically, it just means that the software was able to include the GPS measurements with very high accuracy. But this should mean, these values there should not be taken as a fair assessment of the quality of your processing. These values are going to let you know if the GCP were well included in the project, but they are not going to tell you if your whole project is going to be accurate. For this, you'd rather use checkpoint. So as you can see, there's another table which is just about the 3 GCP that are labeled as checkpoint. In this table, I have again the error in X, Y, and Z, the reprojection error, how many times I clicked in the images to mark them. And here I get the mean, the sigma, and the REMS error. Something very nice, you can see, so this project was a 4 centimeter per pixel GSD, and the GCP, the average error and the RMS error is basically in the range of 1 pixel, which is extremely good for this project. So I saw going in the chat question, the usual question. So how many GCPs and where would you put them? So that's a very, very interesting question. Usually what we recommend is to use 5 GCP for even quite large projects and to spread them evenly in the field. As I mentioned in the intro, there's really 2 different cases. In the case where you have a very good overlap, you have very good image quality, well, in that case, there will be very little drift due to error accumulation, and the GCP are mainly going to be used only for georeferencement, not for improving their accuracy. Now, where do you place them? If you place them all side by side very closely to each other, you have the likelihood that if you do a small mistake, you always do a small mistake in the measurement of this GCP, it can have the effect of a leverage, and a small mistake there, a small degree of mistake could actually introduce quite a large mistake on the other side of your project. For this reason, it's always much better to try as much as possible to spread your GCP all across your project to avoid this leverage effect. Also, I wouldn't put the ground control points too much on the extreme side of the project, because you will have less images on which you can mark the ground control points. So by putting the ground control points a bit more centered, you have more images which see this GCP, and so you can mark them in additional images, and this is going to also improve the accuracy. So I'd like to share this project that we did together with a client. These are 2,890 images followed in multiple flights using a UAV and a RICO camera with a 4 centimeter GSD. In this project, 27 GCP were recorded. Using the latest Pix4D Mapper 1.1, which is going to be released end of May, we did some experiments about the accuracy of the different projects using the ground control points. So without any ground control points, indeed, you get something like a 4 meter inaccuracy in that direction by looking at all the control points on the field. This basically is the error introduced by the geotag, by the GPS, inaccurate GPS on the UAV. However, then by using 5 ground control points, only 5, the error on the 22 other GCP station was of 10 centimeter. Sorry, so GSD means ground sampling distance, is the size of a pixel on the ground. So each pixel is 4 centimeters on the ground. And what's very interesting from this table is that there is a huge difference from using 5 GCP, but then for this particular project, adding more GCP did not really improve much the accuracy of the project, because the content, the visual content and the overlap was so good that the error just from the images was already incredibly small. Now, this is not true for every project. On the left, you would see a project such as described before, so where you have a lot of matches. In this case, yes, you could use possibly only 3 ground control points and place them pretty much wherever you want in the project. However, now on the right, you can see this is the same project, but this was I flew this project much later in the evening, and the light condition was very poor, and the visual content of the image thus was also very, very poor. And you can see that the visual content is so lower in the images that there is potentially much more error accumulation happening in this project. Another thing you can see is basically this project almost divided itself into two parts, the part on the top and the part on the bottom, and there's very little link between these two parts. In this case, adding more than 3 ground control points can really help and improve the accuracy, and is probably needed to improve the accuracy. And I would recommend 2 ways of setting the ground control point in this project, either by treating the 2 subparts as individual and including ground control point in one subpart and the other, or to try to put the ground control points in the part where there was very little match, to try to help the software to improve and to avoid this error accumulation at this place. Now, having said that, this is still not ideal. If you had the choice between adding more GCP and taking the images with better light condition, more overlap, more data, you should always go for more data and better light condition. Adding GCP helps, but it's a complicated way and very requires a lot of work to be done, where usually adding more data would solve all of your problem without having to introduce too many ground control points. I'm going to go quickly now over the most common errors that our support team has been checked when people are using the software. The first one, which is usually the most common one, is people introducing the wrong coordinate system. Basically, if you put the wrong coordinate system, then everything's going to be difficult because the ground control points will not be at the right spot. When you try to measure, everything will be wrong. And usually you can detect when this happens when you go back in the software and you look at the map view. If you don't see the blue crosses in the map view, this probably means that you did a mistake by either having the wrong coordinate system or that you inverted in your text file, the X and Y position. This will either put you back somewhere in the water in totally wrong position or display them all in one single dot. Another type of mistake that is very often done is bad distribution of ground control points. Setting 3 ground control points in a line is not sufficient to define a 3D coordinate system. And basically you will have ambiguities and maybe the project will be tilted in one random direction. Also, if you put them all in a single corner, it may happen that it shifts the whole and you get orientation mistake in the whole project. Another type of mistake is mislabeled GCP. This you would be able to detect from the quality report if you see too many red points in the quality report. If you have inaccurate ground control points, like you're using your iPhone GPS to try to insert ground control points, well, if you have geotags, then you're likely not going to improve anything. You're just going to add more noise to the system, and this is usually going to be difficult. Something also to remember is that the images, they are matching very nicely. So if you tell them to bend toward inaccurate GPS, it might make very, very weird effects on that. So I wouldn't try to use the system with inaccurate GPS. Or maybe actually you could do that with the tolerance setting that I'm going to talk just after this one. Also, something which happens is if you have GCP, but this GCP is in a location in your project which was not able to get calibrated for some reason, because maybe it was a very difficult area. So for that, you would first need to add manual tie points, just as I explained in the previous webinar, to calibrate, to get all the images to calibrate, and then only then, if the images are calibrated, then the ground control points will be taken in account. I'm then going to talk quickly about the tolerance, as this is quite important, and this is one of the new features of the Pix4D Mapper 1.1. Now you have the possibility to set yourself the tolerance, which is basically the expected accuracy of both the geotags and of the ground control point. The default value for the geotag on the software is 5 meters for XY and 10 meters for Z. This is very good for consumer grade GPS. If for some reason you put this value and you set this value to the tolerance too high, like you would put 100 meters in XY and 100 meters in Z, then the geotag will not contribute almost at all to the reconstruction and not help at all the reconstruction. So it's like if you were not using geotags. If you put it too low, so if you would put like 1 millimeter in XY and 1 millimeter in Z, then this will have very strange effects too, as you told the software to really trust the geotags, but actually they are not trustworthy, they are very noisy. The software is going to try to match them as much as possible, and you will get weird effects happening in the reconstruction. Same for ground control points. There you can basically set the expected accuracy of your GPS. If you set a very high value, then it's not going to be taken much in account. And if you put a value which is too low, then you have a very big likelihood that your GCP will not be taken in account for the project. So you have quite a good incentive to set the right value. I'm just going to show you quickly how to do it, how to insert this value. So for the geotags, you go in Image Property, and there you have the list of your images. You can see by default the XY tolerance is 0.1 meter. I'm going to reduce, actually I already changed it before, so by default it's 10 meter, it's 5 meters, but I already changed it. You can set it to, let's say, 0.5 meter. You can set it per image if you want to change it to have very good tuning on each images. But if you need to set all the tolerance of the whole column, you click on the column. Then you right-click with your mouse on the value which you want to set everywhere. And there you'll have a small pop-up telling you that you can replace all the values of this column with the one which is under the mouse. There. Now all the values are this one. Same for the vertical. You could have a 10 meters vertical tolerance. You choose the column, you right-click with the mouse, and you can replace all the values with this one immediately. For the ground control points, you click on the GCP editor. Now you have these two tolerance values. You basically can also change the tolerance of this. If you say that you have very inaccurate GPS because you basically GCP because you collected them on Google Maps, for instance, there you could put an estimate of 10 meter tolerance. And then you can, again, you select the column and you can set that, replace the value for all the GCP. Okay, now just to quickly finalize this webinar, I still have a slide about an alternative way of introducing ground control points in Pix4D Mapper. There are really many ways. We offer a lot of flexibility in how you can introduce ground control points. I just showed today the most efficient way when you have ground control points and reasonable geotags. But if you, for some reason, you don't want to process first and you want to insert ground controls before doing any processing, you can still use the ground control points editor, and you can find many articles on our knowledge base which will show you the alternative way of introducing ground control points in your project for local coordinate system, for some when you don't want to process before doing the processing, you don't want to process before doing the marking, and so on. All right, so I covered a lot of information, but this basically closed most of the questions, most of the topics I wanted to cover about ground control points within an hour. I take the opportunity to announce that we already planned the next webinar for next month, which is going to be about also a new feature that we introduced in Pix4D Mapper 1.1, which is an index calculator specialized for precision agriculture. Basically, it's something that allows you to edit your automosaic, to generate single band and index map like NDVI formulas. You can create, save your own formula, create classes, many things which are very useful for precision agriculture. So this is going to be next month's topic, and you will very soon be able to register it on the similar page. Still, we have workshops that we are hosting in Switzerland in our offices, beginners and advanced user in Lausanne, which is going to happen in July. More information on our website. As usual, you can always get a free trial of Pix4D Mapper directly on our website. You can rent a month starting as low as 260 euro per month. And I'm very happy to introduce that we've put just today last month's webinar about the rayCloud fully downloadable on the web, and you can find this on mapper.pix4d.com. This webinar that I'm just giving now will be available also within a week on this same mapper.pix4d.com. With that, I'd like to thank you all very much for attending this webinar. I hope that you've learned a lot. And I'm going to leave the webinar open for the next 30 minutes, where you can keep chatting with our support team through the questions, and you can get directly a few questions from that. And any way, our support is always available either on the knowledge base or by writing at support@pix4d.com. So with that, thank you very much. It was a pleasure to host this webinar again. I hope you had also pleasure watching it. And well, I hope seeing you next month for next webinar. So I leave the GoToWebinar open for the next 30 minutes, so you can chat with our support team for any questions related to this webinar. Thank you very much. Have a great day.